Okay, so this question is based on the projection. So in this question, what we have to do is to project this B onto the column space of A. So we have to project this matrix, or we can say this vector, onto the column space of A. So this is the question. So how we can proceed with this type of question? One more thing, that this B is obviously not in the column space of A. So if we draw our picture, that uh, if we take if we have this is our column space of A, then what would be the orthogonal complement of this column space, column subspace? Then we know that from the basic fundamental theorem of linear algebra, that the orthogonal complement of this column space would be the left null space, that is null space of A transpose. So these two subspaces are orthogonal, right? Now we have given that let's suppose that this maybe this vector B. So now we have to uh, find the projection of this vector B into the column space of A. So maybe it will look like something that this vector is in the column space of A and it is the projection of B. So how we can write this vector, this is small vector that is in the column space of A and the projection of this B. So since let me take different color, maybe white. Since this white vector is in the column space of A and it is the projection of B, so it will be some combination of A, right? Some combination of the columns of matrix A. So we maybe it how we can write that A, uh, that X vector. So this projected uh, vector will be combinations of the column, right? So this X hat that we are taking, what combination of the column is unknown to us. So that is the one goal that we will find. Also, if you observe that this B mm, can have one more component, and that is that we can project into this that in the left null space of A, right? Or we can say null space of A transpose. So if you compare or with the line projection, suppose you have given this vector B, so we are projecting into the line. So how we project? We project into this line, and also we project into the this orthogonal component. So we have two components of this B, and we call it E and maybe this P. So according to vector addition, how we can write is the B is equals to E plus P, right? So same idea we are extending into the subspaces also. So if it is one projection is in the column space, then the other projection will be in the left null space. So maybe the other vector will be in this subspace that is in the left null subspace, and we call it this E. Now our first goal is to find this this component, right? that is in the column space of A, and it is the projection of B. So we can consider this as a small p, this projected this projected vector, and we can call it p is equals to a x hat. So if we know this x hat, then we will have this projection, right? So how we can find this? Also, if I ask about this e component, then what it will be that e, since we know that b is equals to that p plus e, right? Because we have split the b into these two components, so this b will be the addition of these two, right? And how we can write p as a x hat plus e, then from here e, what it will be, a is equals to b minus a x hat, right? So in this problem, if we know x hat, then we can solve for uh, p and e. Now let's look how we can solve for x hat. Also, I hope that you realize that how we have taken this a x hat. So what does it mean that a, so so since this projected matrix is in the column space of a, then any combination of column, that any combination we are considering as x hat, will be also in the column space of a. So let's find out first of all the x hat. So if you look at the picture, then you will observe that this projection into the column space and the projection into the left null space, that is E, if we take that dot product would be 0. If you take any vector from this the column space and any vector from this left null space, and their product, their dot inner dot product will be 0, since these are orthogonal to each other. How we can write in terms of matrix? So a x hat, so there we are taking some vec projection matrix, so p is a x hat, right? So the transpose of this dot e, how we can write e from here, that is b minus a x hat will be 0, right? If we multiply this, so the same thing I'm writing, right? So now what we can do is, so one more thing, instead of taking this one vector or one combination, we take the complete a matrix, since whatever the vector you can take from this column space, that will be orthogonal to any vector that is in the left null space, so that product will be 0. So now we can proceed further, and we can write that a transpose b minus a transpose a x hat is equals to 0, or we can arrange it like this: a transpose a x hat is equals to a transpose b. So these are the known quantity, right? A transpose a and a transpose b, these are the given in the question, so obviously we can find this x hat. So let's find out, let's first find out a transpose a and then a transpose b, then we will find this x component, x hat component. So a is given here and b is also given. So let's first find out A transpose A. So 1 0 0 and 1 1 0 is the A transpose, and 1 0 0 1 1 0. So you can do the simple multiplication. Now let's find this A transpose B. So A transpose is 1 0 0 and 1 1 0, and B is given in the question, that is 2 3 4, right? So 2 3 4, then you will have this 2 and 5. Now you can put this into this equation. Now we have A transpose A, that is 1 1 1 2, and we don't know about this x hat is equals to 2 5. Now it is nothing but solving Ax is equals to B, right? So how we can do that? We can simply do that by elimination. Apply the elimination. 1 2, it will be 0, and 2 minus 1 1, and this will be x hat, and also we will apply the elimination on the left side, right? So it will be 2, and 5 minus 2 is 3. Now from here we can say that x hat 2 is equals to 3, right? And x hat 1 is equals to, it will be minus 4. You can simply do it by back substitution, right? So from x2 you will get 3, and x1 you will get minus 4. You can check it. So x hat is 3 minus 4. Let's check it. So 3 times 1 3, and minus 8. Okay, so I have done one mistake here. What is, so here it is 1 1, right? And I have wrote 2, so it will be here 1, and if you apply the elimination it will be 0, right? And 2 minus 1 1, correct? And 5 minus 2 3. So if now back substitution, so we will get x hat 2 as 3, and x hat 1 plus 1 into 3 is equals to 2. So x hat 1 will be 2 minus 3, that is minus 1. So overall we can say x hat we will get 3, minus 1 and 3, right? Now if you do the multiplication with this, then minus 1 and plus 3, that is 2, correct? And 0 3, so correct. So we have got this x hat. Now since we have got this x hat, so we can find this projection, right? So what will be, so P is equals to A. So what is A? 1 0 0 and 1 1 0, and x hat what we got is minus 1 or 1, I think minus 1 and 3. So minus 1 and 3. So how much it will be? Minus 1 and 3, that is 2, and 3 and 0. So this projected matrix, this projected vector matrix P that is in the column space of A will be this, right? Now if you have to find this E, how you can find this E? Since we know B and we know this P also, right? So E will be nothing but B minus P. So B is 2 3 4, right? B is in the question 2 3 4, 2 3 4, and P we have found 2 3 0. So if we subtract we will get 0 0 4. Now you can check this E dot P. So E dot P will be 0. You can check simply 2 3 this component and this component are 0, so overall E dot P or E transpose P will be 0. So whatever the answer we have got, these two components are correct. Now one more thing I wanted to tell you about the projection matrix. So what is projection matrix? That so overall thing is thing about the projection matrix is, so so if you have given this vector b, now if you want to project this into some subspaces, then what matrix will do this kind of transformation? So that we call the projection mat. So what matrix will project b into this column space and this left null space? Let's not talk about this. What matrix p, or we can say what projection matrix will transform this b or project into this column space of a? So we have to find this big P, capital P, that is the projection matrix. So once you apply this projection matrix to B, what it will do? It will simply project this B into the column space of A. So how you can find this projection matrix? So from the given equation we can find itself. So let's find out. So we know that P projection is equals to a x hat, and we found x hat, right? So a, so from here we can write x hat. How? So x hat is equals to, how we can write the x hat? So x hat will be a transpose a inverse a transpose b from this equation, right? So we can put this equation, that x hat, here, right? So what is x hat? That is a transpose a whole inverse a transpose b. Or let's take this b in different color, so that, okay, so you see this thing is nothing but P, that projection matrix. So that projection matrix P is equals to a transpose a inverse a transpose. So if you find this thing, so first you have to find this a transpose a inverse, then you will have to multiply, then you will get this projection matrix. Now whatever the projection matrix you will get, up multiply with this b, that projection matrix will transform this b to this projected matrix, that is p. So if you would like to see this also, then we can go for it. Okay, let's find out. So first of all, let's find out this a transpose a inverse. We have already found this a transpose a, right? So we have already found this a transpose a, so that is this one. If we find the inverse of this matrix, we can do that. That will be 2 1 and -1, and here it will be 2 -1, that is 1. So 1 by 1. So that is the inverse of this matrix. Now what we have to do is find this projection matrix, right? So a is 1 0 0 and 1 1 0, and this A transpose A inverse, what we have found is 2 minus 1 minus 1 and 1. So 2 minus 1 minus 1 and 1. I think I have wrote correct. 2 minus 1 minus 1 and 1. And this A transpose, right? So A transpose is 1 0 0 and 1 1 0. Let's multiply first these two matrices. So what we will get, so this is what we will get after multiplication, and now multiply this and this. So after multiplication we have found this projection matrix. Now what I am saying, that if you have to find this projected component, then what you have to do is apply this transformation that will project your matrix B into this P. So that is 1 0 0 0 1 0 and 0 0 0, and B is 2 3 4. Now if you do the multiplication here, you will get 2 3 and 0. So here P, what you have got is 2 3 0. By finding this projection matrix, using this projection matrix, you have got this projected component as 2 3 0, and if you see earlier, you have got this P as 2 3 0. So that is all about how you can find the component on in the column space of A matrix, and how you can find this projection. So that covers lot of things in the projection. So that is all from this question. And one more thing I wanted to say is, so one more thing, that there is more simplified version, that is projection projection of some vector onto line. So, and what we have done is the projection of a vector into the subspaces. So this is the projection into subspaces. So this is more simpler version. So how I have gone through each step, using the same step you can find this projection matrix in this case, and the projection matrix that we have already gone through. Also you can find this x component, so you can follow the same procedure. So that is all. Thank you.